Hi everyone, this is Srikanth, Assistant Professor of EEE Department. In this session, I am going to cover the definitions on network theorems and three-phase voltages. State Thevenin's theorem. Thevenin's theorem states that any linear electrical network containing voltage sources, current sources and resistances can be replaced by a single voltage source in series with a single resistor. This equivalent circuit known as Thevenin equivalent, which will produce the same current voltage characteristics at the terminals of the original network as seen from those terminals. Whereas the voltage magnitude is nothing but the open circuit voltage across the two terminals, and the resistance is the open circuit equivalent resistance between the two terminals by making voltage sources with short circuit and current sources with open circuit. State Norton's theorem. In any linear electrical network containing voltage sources, current sources and resistances can be replaced by an equivalent circuit consisting of a current source in parallel with a resistance. Then that is called a Norton's theorem. This equivalent circuit known as Norton equivalent will produce the same current voltage characteristics at the terminals of original network as seen from those terminals. And here the Norton's current is nothing but, whatever the current source is nothing but a short circuit current between the two terminals, and whereas the resistance is the open circuited equivalent resistance by replacing voltage source with short circuit and current source with open circuit. Both Norton's and Thevenin resistances are same. State maximum power transfer theorem. The maximum power transfer theorem is a principle in electrical engineering that addresses the conditions under which a load resistance will receive the maximum power from a source. The theorem is stated as follows. For maximum power transfer to load, the load resistance must be equal to the source resistance when all internal resistances of the source are taken into account. Mathematically, this can be expressed as load resistance is equals to source resistance. That is nothing but in any circuit which is replaced with a single voltage source in series with a resistance, the maximum power will be transferred from source to load only when the load resistance is equals to the source resistance. Next one states superposition theorem. The superposition theorem principle is used in electrical circuit analysis to simplify the analysis of linear circuit with multiple sources. The theorem states that the response in any linear circuit with multiple independent sources can be determined by considering each source separately while all other sources are turned off. That is nothing but voltage source is replaced with short circuit and current source replaced with open circuit, and then algebraically summing the individual responses. Or we can also state the superposition theorem as superposition theorem states that in any linear bilateral circuit consisting of two or more sources, the response in any element is equals to the sum of responses caused by individual sources acting alone by making other sources as non-operative. The other sources will be replaced. A voltage source is replaced with a short circuit and a current source is replaced with a open circuit. State the steps to solve the superposition theorem. The steps which we need to solve the superposition theorem. First, we need to take only one independent voltage source or current source, and we need to make other sources to non-operative. That is nothing but voltage source replaced with short circuit and current source replaced with open circuit, and obtain the branch currents. Wherever we need to calculate the current, that current we need to calculate, and repeat the above for the other sources. The same thing which we are going to repeat for how many number of sources are available. And then to determine the net branch current, just add all the currents obtained above to get the total branch current because of all the sources. Then we need to add all these three, all the how many number of currents are available, that we need to add. That current is nothing but our resultant current. State the steps to solve the Thevenin's theorem. So for solving Thevenin's theorem, first we need to remove the load resistance and find the open circuit voltage. First we need to remove the load resistance and we need to calculate what is the voltage across the two terminals of the load where it is connected. That is nothing but VOC, and it is also called as open circuit voltage. And the next is we need to calculate Thevenin resistance. For that, we need to deactivate the constant sources, that is voltage source replaced with short circuit and current source replaced with open circuit, and find the internal resistance RTH of the source side looking through the open circuited load terminals. That is nothing but we need to calculate the equivalent resistance by replacing voltage source with short circuit and current source with open circuit. Obtain the Thevenin equivalent circuit by connecting open circuit voltage in series with the RTH, and reconnect the load resistance across the load terminals. Now the load resistance is connected with the load terminals. Next one is state the steps to solve the Norton's theorem. Here, in order to calculate the Norton's theorem, first we need to calculate the Norton's current. So for that, remove the load resistance and find the internal resistance of the source network by deactivating the constant source. That is nothing but first we are calculating the Norton resistance, and then short circuit the load terminals and find the short circuit current. That is nothing but the Norton's current. And Norton's equivalent circuit is drawn by keeping RTH or RN is in parallel with short circuit current or IN. This is the Norton's equivalent circuit. A current source in parallel with the resistance IN and RN. Write some applications of maximum power transfer theorem. Which is maximum power transfer theorem is nothing but which has to reach the load has to take the maximum power. There is a condition. So there should be this maximum power where it is required. Then that type of applications we need to use this maximum power transfer theorem, that is power amplifiers, communication systems and microwave transmission, there which is required the impedance matching and maximum power which has to take. That's why we are going to use this maximum power transfer theorem. Give some method available for measuring three-phase power. That is, there are different methods to calculate the three-phase power based on the connections how we are going to connect. One is single wattmeter method, 2 wattmeter method and 3 wattmeter method. Single wattmeter method is connected to all the three phases and which is going to calculate the three-phase power, and 2 wattmeter method which is going to connect with the three phases which will calculate the power, and 3 wattmeter method which is connected to each phase. 1 wattmeter is connected to one phase and will calculate the power. And what are the advantages of three-phase system? The main advantages of three-phase system is, when we go with single phase system, in some situations there may be a loss of power. That is not possible with the three-phase system. That is, there is a constant power. And when we are having three-phase system, the line to line voltage is high so that we can get the maximum power, that is of high rating. And then we need to maintain the power transmission in the particular economic levels, that is power transmission economics. Next, explain the concept of balanced load. Here, the load is said to be balanced when the magnitudes of all impedances Z phase 1, Z phase 2 and Z phase 3 are equal, and the phase angles of all of them are equal and same nature, either all inductive or all capacitive or all resistive. The magnitude and phase angles of the impedances should be same, then that load is called the balanced load. The next one is, what are the three types of powers used in AC circuits? The first one is real or active or true power. Power is equals to EI cos phi. That is the power which is, this is the real power where we are going to receive. And reactive power, Q is equals to EI sin theta. This is the power in the reactive elements. And apparent power is S is equals to E into I. This is the apparent power. Define real power. Here real power is nothing but the actual power which is consumed in an AC circuit is called the real power, where P is equals to EI cos phi, where cos phi is nothing but the power factor. And this power factor phi is nothing but the phase angle between the voltage and current. And this power factor depends on this phase angle. Define reactive power. Here, the power consumed by the pure reactance in an AC circuit is called reactive power. The unit is var, volt ampere reactive, and Q is equals to EI sin theta. Next one is define apparent power and power factor. The apparent power is the product of the RMS values of voltage and current, where S is equals to VRMS into IRMS. The power factor is the cosine value of phase difference between the voltage and current. It is also the cosine value of the load impedance, and power factor is equals to cos phi. Here, apparent power is nothing but volt ampere power, that is voltage into current, and power factor is nothing but cosine value of phase angle difference between the voltage and current, and this depends on the phase angles of voltage and current. Now, the next one is, what are the advantages of three phase circuits over single phase circuits? So, the first one is generation, transmission, and distribution of three phase power is cheaper, because if we go on taking a single phase supply, and the generation and transmission and distribution is very difficult, and the cost is also increases. That's why all generating stations are going to use the alternators with three phase output, which will generate the three phase output, and that three phase output is going to be transmitted and distributed, and this, the cost which is required for this, for all of these, is less, and it is more efficient, and uniform torque production occurs. Here we are going to get, when we are having a three phase supply, there will be uniform torque production will be is possible in the motors. RA is the resistance at A, and RB is the resistance at B. RC is the resistance at C in star connection. After transforming to delta, what is the resistance between B and C? That is, after converting to delta, each delta connected resistance is equal to the sum of two resistances. It is connected to the product of plus the product of two resistances divided by the remaining resistance. Hence, the resistance between B and C is RC plus RB plus RC RB by RA. Here, let us take this. RA, this is point A, at B, RB, and at C, RC. What is the resistance at RB, RBC, which is asked, where RBC is equals to sum of two resistances RB plus RC plus RB RC by RA. And RA is the resistance at A, RB is the resistance at B, RC is the resistance at C in star connection. After transforming to delta, what is the resistance between A and C? That is RA, RB, RC. Between RA and RC, RA plus RC plus RA RC by RB. The next one is RA is the resistance at A and RB is the resistance at B. RC is the resistance at C in star connection. After transforming to delta, what is the resistance between A and B terminals? That is nothing but RA plus RB plus RA/RB by RC. And state the relationship between line voltage and phase voltage and line current and phase current of a three-phase delta connected system. In delta connected system, the line voltage is equals to phase voltage, and whereas phase current is equals to line current divided by root 3. So here, if it is a star connected, V phase is equals to VL by root 3 and I phase is equals to IL. These are the two differences between the phase voltage and line voltages in star and delta connected systems. And define line voltage. Line voltage is nothing but it is the voltage between the two phases of a three-phase system. A three-phase electrical system, line voltage refers to voltage measured between any two of the three-phase conductors or three phases. A three-phase system consists of three conductors often labeled as A, B and C, and the line voltage is the voltage difference between any pair of these conductors. Any pair of these conductors. A line voltage is commonly denoted as VAB, VBC and VCA, representing the voltage between phases A and B, B and C, and C and A. Define phase voltage. Phase voltage is nothing but it is the voltage between the phase between the conductor of a three-phase system to the neutral. In a three-phase electrical system, the phase voltage refers to the voltage across single-phase winding of a three-phase device or a load. In a balanced three-phase system, each phase is identical, so the phase voltage is the voltage measured across any one of the individual phases. Define internal impedance. The internal impedance of source refers to the opposition or resistance to the flow of electrical current within the source itself. The internal impedance is nothing but it is the opposition or resistance to the flow of current within the source itself, and it is the impedance associated with the internal components of the voltage or current source. And this internal impedance is essential to consider when analyzing and designing the electrical circuits. Next, define Thevenin resistance. Thevenin resistance is the resistance which is calculated across the open circuited terminals where the voltage sources and current sources are replaced with their internal impedances, or we can also take it as voltage source is replaced with short circuit and current source replaced with a open circuit. The Thevenin resistance, often denoted as RTH, it is a concept used in electrical circuit analysis and represents equivalent resistance of a linear electrical network as seen from the two specified terminals. The Thevenin equivalent circuit is a simplified representation that allows complex networks to be replaced with a single voltage source and in series with the resistance. Define Thevenin voltage. The Thevenin voltage is often denoted as VTH. It is a concept used in electrical circuit analysis to represent the open circuit voltage between two specified terminals of a linear electrical network. That is nothing but whatever the load, if we remove the open circuit voltage, if we calculate between the two terminals of the load where we have removed, then that is nothing but the Thevenin voltage. The Thevenin equivalent circuit simplifies a complex network, allowing it to be replaced by a single voltage source and a single resistor. The next one is not define Norton's current. Norton's current is often denoted as IN, and it is the short circuit current between the two terminals of where the load is connected. It is a concept used in electrical circuit analysis to represent the current that would flow between the terminals of a linear electrical network when the network is replaced by a single current source and a single resistor. This concept is a part of Norton's theorem, which is an alternative way to analyze the and simplify electrical circuits. Define phase angle. Phase angle is nothing but what is the difference between the two waveforms. What is the difference? Phase angle difference between the two waveforms is called phase angle. The phase angle in the context of electrical signals or waveforms refers to the angular difference in degrees or radians between two sinusoidal waveforms or signals. Angular difference in degrees or radians between two sinusoidal waveforms or signals. It represents the relative timing or displacement between corresponding points on the two waveforms and is measured in terms of degrees or radians. Define out of phase. In electricity, out of phase is nothing but if the two waveforms are displaced by an angle of 180 degrees, then those two waveforms are said to be in out of phase. Define in phase. When the phase angle difference between the two waveforms is zero, then those two waveforms are said to be in phase. In phase, in the context of electricity, refers to a condition where two alternating current waveforms, such as voltage and current, reach their maximum and minimum values at the same time and have the same frequency. In other words, corresponding points on the waveforms align in time, resulting in a phase relationship of 0 degrees. Next, define amplitude. Amplitude is nothing but it is the maximum value in the waveform. The amplitude refers to the maximum extent of a varying quantity from its central value or baseline. In the context of waves, oscillations, or periodic signals, amplitude represents the maximum displacement or variation from the equilibrium position. It is often associated with the intensity, strength, or magnitude of the wave. These are all about the definitions of network theorems and three-phase circuits. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.